Yeah.
Justin's.
We're recording, so be careful. Daisy.
He's gonna hear that.
Right, so let's do it then. So, because this is function machines, I'm going to keep it like function machines. Are you all ready to write this down? Okay, so we've got an input. The input is for A. Work out the output when the input's 27. So I'm going to put 27 in. I am going to add 15 to 27, and what do I get?
42.
42. Now, for some people, you just made a mistake adding up. It's not a big problem. Sort that out. You just need to be careful, I guess, as long as you know what you're doing. Yeah. Nope. I know why you're doing that, aren't you? Because you're doing bed maths, aren't you? Yeah, order of operations. Now that only comes into play when you're just given the expression. This is a number machine where the way I would write it, if the input was x, it would be x plus 15, and then it would be x plus 15 brackets that you do first and divide by 6. All right, so that's how it would look. But I understand this is a good point to make. But when we do a function machine, we know what order it is. So 42, and then 42 is divided by 6, and we get the answer 7. Okay? B, we put the input in is -6. -6 subtract, add 15 is 9. 9 divided by 6 is 1.5. Okay. Now, on the whole, I think people were fine with that. Not too many issues. I think some people might have got confused when they were trying to do 9 divided by 6 and getting a decimal and thinking that wasn't allowed or something like that. But on the whole, that was all right. The trouble came for a lot of people. Is that a question?
Yeah, for the. What you just did opposite, like.
Okay, so like I was saying, C, we want to know what the input is. So I'm going to put a question mark, and we do plus 15 into the question mark. Then we divide by 6. And what we know is the answer we get out is 9. So what I told you to do with the function machine is to work backwards. So 9, we have to undo. What's it called? Undoing, we do the what operation? But you're right, the inverse operation. What's the inverse of dividing by 6? Multiplying by 6. So first of all, we do 9 times 6, and we get 54. And then we have to put that into what's the inverse of minus 15. Okay, 54 subtract 15 is. So take the 10 gives me 44. Take off 5 gives me 39. So it's 39. Okay. All right. Make sense? Can I get you to do D yourself then, just laying it out like this? So D, work out the input when the output is 0. So we're going to start with 0. Do that. Do that. Ready? What do we get? 0? 6 is?
0.
0. 0 subtract 15?
Negative 15.
Negative 15. Okay, cool. Next sheets, just quickly. This is, I tried to help Lena with it. I don't think we can get too far, but that's all right. What we have to do is we have to add on what we've currently been doing, which is writing and solving an equation. But this would be considered harder than all the equations you've currently done, unless on the Samson thing the other day, you got to like level 5 or something, right? So it's not hard, but I'm going to give you the model solution, Jack. Is that, I can only see you making a face. Who created it?
By itself.
Oh, yeah, so good reason. Okay. Good reason. Okay, let's write this as an equation. So the input is y, times it by 7 is 7y's, subtract 13 equals, instead of a number, it's actually equal to 3y's. Now this does give me a very good opportunity to go through the method that I'm expecting of you today when we are. Remember what it was called? Using, we are, but we are writing something else, beginning with E. It kind of sounds like what this is called. What's that called? What's that sign called? Equals. Do you remember what I said? Good. Equivalence transformations. Do you remember I said that? So this is what I'm going to do. I am going to rewrite this as 7y subtract 13. Okay? But I'm going to add 13. Do you know why?
Oh yeah.
Because that gets rid of this one, doesn't it? What's on here now? Simplified becomes just 7y's. What's on this side? That 3y plus 13. Now, you might say, but that hasn't helped. I'm still in a bad position. I'm still no closer. But actually, it is a bit closer. And this is where you're using this method to a higher level, but we're still using the same method. You right, Ryan? You good with the paper on the table?
Will this probably be on like the 7-8?
Could be. Maybe even like next year's stuff. Caleb? Yeah, go for it.
When it's telling you that 7y is equal to 3y plus 14, which means that 14 is the difference between 7y and 3y and 4y.
Okay, so, well, let's do it in the way that we've been doing it, which is, like Kayla did say, this, alright, is the same as this. Therefore, logically speaking, which is what Kayla's doing, this 13 has to be the difference between 3y and 7y. I'm going to do it a different way, which is, I'm actually going to write it as 7y subtract 3y equals 3y subtract 3y plus 13. Why did I do that? Because that gets rid of the 3y. So on this side, I'm now left with just the 13. What am I left with on this side?
4y.
4y. 7, remember we did this before, didn't we? You're not even writing this down. Not any of it. Okay. So what's 7y's? Subtract 3y's? 4y's, yeah? A lot of people, not you guys, but a lot of people would write that as just 4y. Not y. 4. Why would they do that?
Because since it's 4y, they just put 4. They're too lazy.
No, it's not laziness, actually, but I hope you're not speaking from your own experience there. No, I'm just saying that. It's not laziness. It's 7 subtract 3 is 4. Y subtract y is 0. So they think they do it separately, right? Remember we talked about that before when we were collecting like terms? y subtract y gets rid of the y's, but it's not. Remember, I have 7 y's, and I'm going to subtract 3 y's. So how many y's am I left with? 4 of them.
Oh.
So we just write 4 y's. Whereas people that don't think of it as the language, they just see numbers and letters on a page. They just think y subtract y, 7 subtract 3, do it separately. Yeah?
If I saw this when I was in like lower primary, I'd be like,
Yeah.
wait.
But you're not in lower primary. But we still have a final step.
What, without optimizing this kind of I add?
No, because 7 minus 13, got to keep that separate. I wouldn't do that. I'd never take what's called the variable out, the y, okay? But we're left with still 4y is equals 13, so we've got to,
Divide by 4.
so I'm going to do 4y's divide by 4 is the same thing as 13 divide by 4, which means the input, the y, is equal to, it's actually,
That's what we calculate.
well, I don't mind, but you could, yeah, at the moment you can definitely. I would expect like my M4s to tell me it's 3.25 because it's like doing 12 divided by 4 and 1 divided by 4. You happy with that? 13 is 12 and 1. 12 divided by 4 is 3. 1 divided by 4. We could either write it as 3 and 1/4, which you should be okay with, or 3.25. Okay.